Hello everyone, this is Dr. A.P. Hivrekar from Vidyapratishthan's Kamal Nayan Bajaj Institute of Engineering and Technology, Baramati. Today we are going to discuss problems on half-range Fourier Sine series. Outline of this lecture is as follows. We will just look at introduction, then what are applications of Fourier Sine series, then what exactly Fourier Sine series is, then we will look at method for solving the problems, and finally we will discuss problems based on half-range Fourier series. So as we know that Fourier series, if the period is t is equal to 2l and interval is c less than or equal to x is less than or equal to c plus 2l, is given by fx is a0 by 2 plus sigma an cos of n pi x by l plus bn sin of n pi x by l, where Fourier coefficients are given by a0 is 1 by l integration of fx dx from c to c plus 2l. An is 1 by l integration of fx cos of n pi x dx. It limits for integration are c to c plus 2l, and formula for bn is fx integration of fx sin of n pi x dx. Limits for integration are c to c plus 2l. So this everybody knows. Now where we can apply half-range Fourier Sine series. It is applicable in examining mechanical vibrations in engineering structures, useful in designing digital filters in electrical engineering, analyzing distortion in telecommunication channels, understanding functions which can help to provide in-depth understanding of that function, and analyzing signal. These are few applications where half-range Fourier Sine series is useful. So what exactly half-range Fourier Sine series is? So expression for fx means function fx is given by sigma bn sin of n pi x by l, where n varies from 1 to infinity. When we are finding half-range Fourier Sine series, Fourier coefficient a0 is 0 as well as Fourier coefficient an is also 0, and obviously when we are dealing with half-range Fourier Sine series, interval we are considering as 0 less than or equal to x less than or equal to l. Here formula for bn is 2 by l integration fx sin of n pi x by l dx, where limits for integration are 0 to l. So these formulas are most important while dealing with the problems. So we will see what exactly is the method of solving problems. So first step, that is we have to write formula for half-range Fourier Sine series, which is given by fx is equal to sigma bn sin of n pi x, where n is from 1 to infinity. In this case a0 is 0 and an is also 0. Then we find what is value of l depending on given interval, and after that we will apply formula for bn, which is given by 2 by l integration of fx sin of n pi x by l dx, where limits for integration are 0 to l. Once we find value of bn, then we substitute that value in this expression for fx, and finally we get required half-range Fourier Sine series. Then obviously here interval is 0 less than or equal to x less than or equal to. So we'll consider few examples based on half-range Fourier Sine series. Problem number 1, first problem we will discuss as find half-range Fourier Sine series for function fx is equal to x in the interval 0 less than or equal to x less than or equal to pi. So while dealing with this problem, we follow the steps which we have just considered, that is method of solving problems of half-range Fourier Sine series. As we know that formula here is fx is given by sigma bn sine of n pi x by L, where n is from 1 to infinity, a0 value is 0 and an is also 0, and formula for bn is 2 by L 0 to L fx sine of n pi x by L dx, where limits for integration are 0 to L. Now here we have given function f. We will write value of x, f of x in this particular formula. So bn is, first we will find what is L. So here we have interval is, standard interval is 0 less than or equal to x less than or equal to L. So if we compare this interval with this given function, we will find length of interval here is 0 to pi. So value of L is pi. So it is 2 by pi integration 0 to pi, because L is pi, and sine of fx is x, so it is x, then sine of n pi x by pi dx, or that will be 2 by pi integration 0 to pi x into this pi get cancelled, so angle will be sine of nx dx. So as we know, there is standard result formula when function is of type uv dx, when it is at or ae, means algebraic into trigonometry or algebraic into exponential. So it is uv1 minus u dash v2 plus u double dash v3 and so on. So v1 is integration of v, u dash is derivative of u, and so we can apply this formula over here, that is we have 2 by pi, then first function as it is x, u is x, v is sine nx, and integration of sine is minus cos. So here we have, this is minus cos of nx divided by n. Integration of sine of nx is minus cos of nx by n. Then next step will be derivative of x. So derivative of x is 1. Then integration of, erase this. Then integration of this term, minus cos of nx by n, that is minus sine of nx divided by n into n, that gives n square. Next term will not be there because derivative of 1 will be 0. So limits for integration are 0 to pi. So here we have, if you substitute this value, as we know that sine of 0 is 0, sine of n pi, where we are taking n as 1, 2, 3, 4 natural number, is 0. So we have, this term will be 0 for upper as well as lower limit. And when we are applying x as 0 for lower limit, this term becomes 0. So only we need to calculate first term with upper limit. What is upper limit? Upper limit is pi. So it is minus 1 by n and x is pi, cos of x is pi. So it is cos of n pi. So that will be, this pi get cancelled, minus 2 by n into cos of n pi, and cos of n pi is minus 1 power n. So cos of n pi is minus 1 power n. So we have final answer, that is for bn value we have this. So finally we have Fourier series fx is sigma bn sine of n pi x by l. So bn value we got this. Then finally we have, so here Fourier series fx is given by sigma bn sine of n pi x by l, but here l is pi, so it is sine of n pi x by l, where n is from 1 to infinity. So here in this case l is pi, so we have bn value is minus 2 into sigma, pi pi get cancelled, so it is this, yes, sigma bn value is 2 by n, so it is sine of nx divided by n, where n is from 1 to infinity. So that is our final answer, that is value of fx. Now we'll discuss next problem. Find Fourier half-range Fourier Sine series for function fx is 2x minus 1, interval 0 less than x less than 1. As usual, we have formula is fx is bn sine of n pi x by l, where here a0 value is 0, of an is also 0, and formula for bn is 2 by l integration 0 to l fx sine of n pi x by l dx. So first we try to find value of interval is 0 to 1. So standard interval is 0 to l. So we have l is 1. So value of bn is 2 by 1 integration 0 to 1, because l is 1. Then sine of n pi x by l, and here we have, so function is 2x minus, we write function as 2x minus 1, and just see that sine of n pi x by l, l is 1, so this angle will be sine of n pi x, so it is multiplied by sine of n pi x and then dx. So this will be uv formula we can apply. So integration of uv dx is uv1 minus u dash v2 plus u double dash v3 and so on. So first function we have is 2x minus 1. So I will write here first function, integration of second means sine function, that is minus cos of n pi x divided by n pi minus derivative of first function, which is 2x minus 1 derivative is 2, then integration of minus cos of n pi x by n pi, that will be sine of n pi x divided by n square pi square. Next term will not be there because derivative of 2 will be 0, and obviously we know that sine of n pi is 0 as well as sine of 0 is 0, so this term becomes 0. So we need to calculate only first term for upper as well as lower limit. So it is 2 for upper limit I am calculating, otherwise we can take n pi outside, 2 by n pi will take outside, then this minus sign also will take it outside, and then we calculate for upper limit. So upper limit is x, so it is 2 into 1 minus 1 into cos of n pi, x is 1, minus because of lower limit. So it is 2 into 0 is 0, then minus 1 into cos of 0. Cos 0 is 1. We know that cos of n pi is minus 1 power n, cos of 0 is 0, right? So we get here minus 2 by n pi into 2 minus 1 is 1, cos of n pi is minus 1 power n, minus of minus is plus, and cos 0 is 1. So this value will be minus 2 by n pi minus 1 power n plus 1. So finally we have fx, which will be minus 2 by pi, we can take it outside, then sigma n is from 1 to infinity minus 1 power n plus 1 divided by n, and angle will be sine of n pi x. So which is our final answer, which is our final answer. I hope you are getting this. Then we will go to another problem. Bn value we already got, minus 2 by n pi. Yes. Next problem will be find half-range Fourier Sine series for function fx is 2 minus x. So here we have interval, formula for fx, formula for bn. What exactly we have to do here? We have to look at function which is 2 minus x, interval is 0 to 2. So what is value of L? Length of half range Fourier series is L. So 0 to 2 length is 2. So L value is 2. So Bn value is 2 by 2. 0 to 2. Value of function is 2 minus x into sine of n pi x by 2, then dx. Again we apply formula integration of uv dx, that will be uv1 minus u dash v2 plus u double dash v3 and so on. So this will be first function as it is, that is 2 minus x, integration of sine is minus cos, sine of integration of sine of ax dx is minus cos of ax divided by a, and here a is n pi by 2. So 1 by a will be 2 by n pi. So that's why it is 2 by n pi with minus sign, because integration of sine is minus cos. So it is cos of n pi x by 2, then minus derivative of 2 minus x is minus 1, then integration of cos is sine, so it will be minus 2 into 2 is 4, n pi into n pi is n square pi square, sine of n pi x by 2. Then next term will not be there because derivative of minus 1 will be 0. So when we apply lower limit, sine 0 is 0, sine of n pi when x is 2, 2 to get cancelled, sine of n pi is 0. So sine 0, 0, sine of n pi is 0. When we apply upper limit, when x is 2, 2 minus 2 gives 0. Means we need to only calculate first term. with lower limit, and because of lower limit it is minus sign, and here already we have minus, so it is minus of minus is plus 2 by n pi. Apply lower limit, x at 0 means 2 minus 0 is 2, and then cos of x is 0, so cos 0. So this will be 4 by n pi. This will be 4 by n pi. And so finally we have fx, which will be sigma bn sine of n pi x by 2, where n is 1 to infinity, and that is 4 by pi sigma sine of n pi x by 2, this divided by n, where n is from 1 to infinity. So that will be our final answer. So value of Bn is 4 by n pi, and final answer means value of fx is 4 by pi sigma sine of n pi x by 2 divided by n, where n is from 1 to infinity. So I wish you all the best, happy learning, and thank you for watching this particular video.